Okay, so for week 1, we're going to discuss number systems. So for number system, our learning outcomes would be to convert different number system from different form to another and perform addition of signed and unsigned binary and represent decimal numbers in binary. So as you can see here, we have different concepts that we need to understand. First is the logic circuit. The logic circuit is the one who is responsible in performing logical operation used for controlling or processing functions in digital systems. So the digital system, so by definition, is the one who manipulate discrete elements of information represented in zeros and ones. And abstraction is the hiding the unneeded information to avoid complexity. So as you can see here, guys, when you design a system, you need to understand that the more that you input or the more that you visualize in your system, it is harder for you to understand or to pinpoint or troubleshoot the error if there occurs. No? Pag may nag-occur kang error or may nag-occur kang dapat mong i-correct, so the more na marami kang nakalagay or the more input that you have, the more complex is your program or your system will be. So the important thing here is to um, make it simple, no? Make it simple or as long as the significant ones po yung ating nilalagay. So in the number system, we have different kinds of terms. So we have unit, which is this is the single object. Then next is the number, which symbolizes or represents a unit or quantity. Then yung base natin, which signifies the number of symbols used in a number system. The highest value in a number system is always one less than the base of the system. So, ano yung number systems natin in digital system? We have the binary. So, ang sa binary natin, dalawa lang yung ginagamit natin. We have the 1 and the 0. So, yung tinatawag nating binary digits. So, pag pinagsama natin yon magiging bits. No? So, again, 1 or 0 or yung tinatawag nating mark and space. No? So, 1 is meron tayong output and 0, wala. No? Then, octal, gumagamit tayo ng 8 digits. We have 0, 1, 2, 3, 4, 5, 6, and 7. And pag sa hexadecimal naman, gagamit tayo ng 10 decimal digits and kasama na doon yung A, B, C, D, E, and F. So positional notation, so the position determines whether the value of a digit is high or low. Numbers can be expanded in a power series. So si power series naman po is inintroduce sa inyo sa advanced engineering mathematics. So useful in finding the decimal equivalent of a number expressed uh, in a system. So we have here an example. We have here 4781. Ang base natin is 10. So how would we do that? So magkakaroon tayo ng answer na 4. Then multiplied natin sa 10 raised to 3. Then 7 times 10 raised to 2 plus 8 times 10 raised to 1 plus 1 times 10 raised to 0. So equivalent yan is 4781 base 10. So yung 1101 base 2, so magkakaroon naman tayo dyan ng 1 times 2 raised to 3 plus 1 times 2 raised to 2 plus 0 times 2 raised to 1 plus 1 times 2 raised to 0. So that will be also equivalent to 1101. So whatever the base is, yun yung power na imumultiply mo sa kanya raised to the kung pang ilan siya. So number-based conversion, decimal to binary. So it involves dividing the decimal number by 2 to give an integer quotient. The remainder 0 or 1 will be the coefficient of the binary number. So you need to continue dividing the integer quotient until it becomes 0. So write the coefficients in descending subscript order. So that are the steps of converting decimal to binary. So example, convert 11 base 10 to binary. So what you need to do is 11 divided by 2. So we have quotient of 5. So may remainder ka daw na 1. Okay? So 11 divided by 2. may quotient kang 5, then yun yung remainder mo natitira. So 10 lang naman yung matitira, so may remainder kang 1. Then 5 divided by 2, so may quotient kang 2, may remainder kang 1. So 2 divided by 2, so 1 ang makukuha mo. So may remainder ka, wala po. So ang remainder mo would be 0. Then 1 divided by 2, kailangan pa rin po siya i-divide, no? So ang sabi po dito is to continue divide until it becomes 0. So 1 divided by 2 is equal to 0. May remainder pa po? Yes. So 1. So therefore, babasahin lang natin siya, no, papataas. Again, write the coefficients in descending subscript order. Therefore, to convert decimal to binary, you will have 11 base 10 is equal to 1011 base 2. So how to convert decimal to octal? So to convert decimal to octal, it involves dividing the decimal number by 8 to give an integer quotient. The remainder, 0 to 8, will be the coefficient of the binary number, and continue dividing the integer quotient until also it becomes 0. Write the coefficients in descending subscript order. So here we have an example. Convert 153 base 10 to octal. So what we have to do is to also do the same that we have did earlier. So 153 divided by 8. So ano yung quotient natin? 19. So what is the remainder? We have 1. Then 19 divided by 8. So we have 2. So ano yung remainder natin? 3. Okay, so kasi 8 times 2 is 16. So ano yung natira? 3. Then 2 divided by 8 is 0. So dahil nag-0 na siya, magsa-stop na tayo doon. So what we have here is 2. So ngayon po, ang gagawin natin is babasahin lang natin siya papataas. So descending subscript order. Therefore, 153 base 10 is equal to 231 base e. So that is your octal conversion po na ng ating decimal value. So, number to base conversion naman ni decimal to binary. So, paano naman siya from decimal to binary? So, the decimal fraction is multiplied to 2 to give an integer and a fraction. The integer will be the coefficient of the binary number. The process continues until the fraction becomes 0. So, convert 0.6875 base 10 to binary. So we need to multiply 0.6875 to binary. So we will have here 0.6875 times 2. Then we will have 0.3750. So yung ating integer quotient would be 1. Okay, so we do that again, 3750 times 2. So we will have 0.7500. Ang ating integer quotient would be 0. Then 0.7500 times 2, we will have 0.5000. So magkakaroon tayo ng 1. And then 0.5 times 2, kakaroon tayo ng 0 fraction. So babasahin naman natin siya this time ng pababa. So magkakaroon tayo ng 0.6875 base 10, which is equal to 1011 base 2. So, number to base conversion naman pag decimal to octal. So, when it comes to decimal to octal, what we have to do is similar to decimal fraction lang siya to binary conversion, wherein this time, imumultiply lang natin yung decimal fraction by 8. Okay? So, same lang po. So, please do refer to your decimal to binary conversion and multiply the decimal fraction by 8. So when it comes to binary to octal naman po, this is a partition wherein the binary numbers are grouped into 3 digits. Each octal digit is assigned 3 binary bits. Each group of 3 binary bits has a value from 0 to 7. Ibig sabihin po, you need to partition yung binary natin ng tatluhan. So 101, then 100, 011, 010, ganun po, dire-diretso. Then you need to convert that every 3 bits or 3 binary bits may value yan from 0 to 7. Okay? So that would be the conversion from binary to octal. So pag binary naman to hexadecimal, so siya naman ipapartition mo naman siya by 4 naman. Kung si octal is by 3, si hexadecimal naman is by 4 naman po. Pero this time is, meron din po, i-open din natin for conversion is gagamit tayo from 0 to F. So binary addition, so when we have binary addition, it is similar to decimal addition. If the sum of two numbers cannot be expressed as a single digit, so carry 1 into the next column. Okay? So add 011 base 2 and 0101 base 2. So when we add them, so 1 plus 1, so 0, then carry 1, then 1 plus 1 plus 0, 0, carry 1 ulit, then 1 plus 1, 0 plus 1, di 1. Then 1 plus 0 plus 0, 1. So ang sagot po natin is 1, 1, 0, 0. So binary addition with overflow. So pag overflow naman is yung wala ka na i-carry over pero kailangan mo pa rin siyang i-carry doon sa kabila even though wala nang digit doon. So overflow occurs if the sum does not fit in the available digits. So if there is an overflow, the leftmost digit or yung MSB, kasi yung nasa kabila naman is yung LSB. So yung MSB or most significant digit natin will be discarded. So compute for the 4-bit sum of 1101 base 2 and 0101 base 2. If the fifth digit is discarded, so the final sum is 0010 base 2. Okay, so what you need to do there is add. So 1 plus 1, 0, carry 1. 1 plus 0 plus 0 plus, 1 plus 0 plus 0, 1. Okay, so wala tayong carry over. 1 plus 1, 0, carry 1 ulit. Then 1 plus 1, so dapat yon ay, di ba, 0, then carry 1. So ngayon, magkakaroon tayo ng overflow. Si 1, i-carry mo, then ibababa mo siya. So your final answer would be 10010. So sign or magnitude numbers. So for sign and magnitude numbers, these are written with the MSB signifying the sign. If the MSB is 0, the number is positive. So if the MSB is 1, the number is negative. Please take note, if the MSB is 0, that would be positive. If it is 1, then it is negative. 0 is represented two ways. We have positive 0 and negative 0. So it is the difficulty to perform ordinary binary addition on sign magnitude numbers. So the example here is to write positive 3 and negative 3 as 4-bit sign magnitude numbers. So sabi dito po, we have positive 3 base 10, so that would be equal to 0011 base 2, and negative 3 base 10, that would be equal to 1011. Okay, so the sign and magnitude highly differs, na hindi po ibig sabihin na yung may positive or negative sign, so that produces the same output. So two's complement. So sa two's complement, it overcomes the limitation of sign magnitude number. So if MSB is 0, the number is positive. So if MSB is 1, the number is negative. So goes through the process taking the two's complement. So flip the bits and add 1 to the least significant bit position, and useful in finding the representation of a negative number and in determining the magnitude of negative number. So the example here is to find the representation of negative 4 base 10 as the 4-bit 2's complement number. So we have 2 base 10, so that would be equal to 0010 base 2. Flip bits natin. So gagawin natin is babaliktarin mo. So yung 0, 0, gagawin natin 1. Then yung 1, gagawin mo 0. Then yung 0, gagawin mong 1. So magkakaroon tayo ng flip bits, which is 1101 base 2. So mag-add daw tayo ng 1 doon sa flip bits. So doon sa flip bits po ha, hindi doon sa conversion. Okay? So 1101 base 2 plus 0001 base 2. So add 1 lang po ha. So plus, so that would be equal to 1110 base 2. So that is the 2's complement na po yun. Okay? So arithmetic with 2's complement numbers. So for the arithmetic of 2's complement numbers, if the two numbers are both positive, add using ordinary binary addition. So if one is negative, obtain its 2's complement and proceed with ordinary binary addition. If both numbers are negative, obtain both 2's complements and proceed with binary addition. If the sum is positive, the magnitude is easily obtained. If the sum is negative, the magnitude is obtained by taking the 2's complement of the sum. Okay, so paano po sir intindihin nyo? So easy. All you have to do is always make sure that your even the ones that you will add, no, yung pag-aadin mo, kailangan positive siya. Ngayon, kung may negative dyan, even your sum, you need first to take the 2's complement of that number. Okay, so kung mag-a-add ka, kailangan i-make sure mo na positive yung i-add mo. Pag may negative or parehas silang negative, kailangan mo munang kunin yung 2's complements. Then, pag ang sagot mo is negative, kailangan mo muna din kunin yung 2's complement nun. Okay, so all in all, so to summarize this, you need to have a positive number to add and to have as your output. Binary codes, discrete pieces of information are transformed into what looks like binary numbers, but the meaning is unlike of that binary numbers. So these are easily read by humans, use more bits than the equivalent binary numbers, require a minimum of 4 bits per digit. Okay? So ito yung binabasa natin na apatan, no? So 1011 ganon. So magbabasa tayo ng apat-apat, mga ganon. So BCD and 84, -2, -1. So si BCD use 10 out of possible 16-bit combinations. Both are examples of weighted code. BCD columns are assigned positive weights 8421 and 8421. -21 columns are assigned and positive negative weights. Conversion is similar to how hexadecimal numbers are written, but only up to the equivalent of 9 base 10. Okay, so it is stated here that we need to have the value of 20 base 10 into BCD. So equivalent po siya sa 0010 0000 BCD. Then equivalent din siya sa 011 0000084 -2 -1 if converted to BCD and the said value. So 2421 and excess dash 3. So use 10 out of possible 16-bit combinations. Both are examples of self-complementing code. So 20 base 10 is equal to 0010 0000 2421 and also equal to 0101 0011 XS dash 3. Gray code. For gray code, not only one bit in the code group changes in going from one number to the next. This is non-weighted and uses the entire combination of 16 bits for 4-bit numbers. Okay, so that would be all for your week 1 discussion. Okay, so let's, since we have time, let's proceed to week 2. Okay, so for week 2, we're going to discuss binary logic and logic gates. So our learning outcomes for Boolean logic and logic gates is to describe logical operators using truth tables, recognize the different graphical symbols associated with the logical operators, and third is to evaluate the output of the simple logic circuit. So these are your learning outcomes that by the end of this discussion is you must have or you must have understand as a outcome of our discussion. So first, we need to define binary logic. So by binary logic, it is consisted of binary variables and logical operators. So our variables are designated by letters and of the alphabet and have two possible values. We only have 1 and 0. So three basic logical operators. We have AND, OR, and NOT, each resulting in one binary value. So when this is operated, AND, or NOT, then we will have a truth table. Then a truth table or a Boolean equation can be used to describe the relationship between inputs and the output. So we will discuss AND operation first. So for AND, AND operation, it is represented by a dot or the absence of a dot. The output is 1 if and only if both inputs are 1. So that is the only thing that you need to remember. So to the inputs, both inputs should be 1 for your output to be 1. So if either which is not 1, kung ang isa doon ay hindi 0, hindi 1, so ang output mo is automatic 0. So the truth table for the AND operation being input variables and Z being the output variables. So the number of rows indicates the number of possible combination. So this is the four combination, no, ng ating mga inputs. If we only have two inputs, ha? So if we have two inputs for your AND gate, so pag ang dalawang input mo ay wala pong or it is not 1, so matic yun po ay 0. Pag ang isa naman po, let's say your second input is 1 pero yung una mong input is 0, so that will be always 0 pa din. This again is for your AND operation. For pag naman siya ay yung first input mo ay 1, yung second mo is 0, that will still be 0. Pero pag ang input natin, your first and your second is 1, then your output is 1. So that would be for AND operation. So for OR operation naman, this is represented by plus sign. The output is 1 if either input or both inputs is 1. The output is 0 if both inputs is 0. So let's check our truth table here. So kung nakikita nyo, our output is symbolized by x plus y. Then if both inputs are 0, so 0 din yung sagot. Pero kung maalin ng inputs ay may 1, no? May value ng 1 kahit yung isa ay 0, the output will be 1 pa din po. So if both input is 1, so 1 and 1, so your output is 1. So ang kailangan mo lang isipin when it comes to OR is if ang isang value ng input ay may 1, no? Pag wala, that would be automatic 0. So for NOT operation, so it is represented by a prime or an overbar. Okay? So pwedeng maalin dyan. So pwede siyang z is equal to x prime or z is equal to x bar. No, pwedeng maalin dyan yung symbol niya. So it negates or complements the input variable so that if the input is 1, the output is 0. If the input is 0, the output is 1. So simple lang. Kung ano po yung input natin, then take the complement of that. No? Ganun naman po talaga pag nagamit tayo ng prime. No? So pag nag-prime tayo ng isang number, so you would take the complement of that number. So the complement of 0 is 1. Siyempre, sabi po kanina, you will use two kinds or two set lang ng number which is 0 and 1 lang po. Now, if the input is 1, then your answer is for NOT operation is 0. So logical operations then, no? So we have NAND, NOR, XOR, and XNOR. So pag naman meron tayong NAND, si NAND naman po is AND na followed by NOT operation. So the output is the negation of the AND operation. Okay? Pag NOR naman po, makukuha naman natin is OR followed by a NOT operation. The output is the negation of the OR operation. While the XOR is an exclusive OR operation, the output is 1 if and only if either input, hindi po both, is 1. Okay? So, please take that into your mind, no? So dapat the output is 1 if and only if, no, yung isang input ay 1, hindi po both. Unlike yung katulad nung huli natin diniscuss, no? So sa or na basta may isa, no, this time no po. So sa XNOR operation, so exclusive OR operation followed by a NOT operation. The output is the negation of the XOR operation. So meron tayo ditong truth table. Okay, so for NAND, NOR, XOR, and XNOR. Okay, so we have here the input 0011 for X, then 0101 for Y. So pag sa NAND operation, doon muna tayo sa Z is equal to XY prime. Ang makukuha natin when we have 00 is 1. Then pag naman po 01, 1. Then 101. Then pag 11 is 0, which is the complete opposite naman po yon or complete negation of our AND. No? Then pag naman po NOR operation, makukuha natin for 00 would be 1 and lahat ng may 1 is 0000. Okay, so ang magkakaroon ka lang na output would be 0. If both inputs are 0, then you will have a 1 as output. Then for XOR operation, so magkakaroon ka lang ng output if ang ating value has only one, no, iisa lang yung one doon sa value niya. So we have 0 1 and 1 0. So doon ka lang magkakaroon ng answer. Then pag naman XNOR, it is a negation of the XOR naman. So kabaligtaran naman siya ni XOR. So ngayon this time ang mangyayari naman, so any inputs, no, na basta may same. So this time, magkakaroon ka ng 0, 0, then 1 yung output mo. So yung 0, 1 at 1, 0, 0 na yung output mo doon. Therefore, yung 1, 1 is 1. So if you are confused, no? If you are confused, you could study naman the truth table of different logical operators. Then you would understand, no, how it works. So, ito yung graphical symbols natin for the logic gates. So, ito yung mga inputs na nilalagay natin. Maybe, gawin man natin siyang 0 or 1 or 1 or 0. Then, yun yung magiging output niya dito. Okay? So, that this X and Y are your input and this is your output. Okay? So, for AND gate, this is the symbol. This is for OR gate. For NOT gate, for XOR gate, NAND gate. So si NAND gate, ang gagawin lang natin, ang pinagkaiba lang po niya is yung output mo is hollow po yung bubble. No? Opposite po yung walang color yung bubble natin dito. Then NOR gate po, buffer gate, then XNOR gate. Combinational circuit. So combinational circuits po, so dito ay yung pag may one or more ka ng interconnected logic gates, the output is immediately produced when input values change. It requires analysis of individual gates inputs and output until the final gate that will be determined has the output of the entire circuit. Meaning, if it's a 3 or more combination, so the final gate would have the answer for the whole combinational circuit. So the truth table is useful for tracing the signals from input to output. There are two raised to n possible combination of the input value where n is the number of input variables. So let's have an example here. We have f, which is equal to x plus y, then multiplied to z. So we have here different combinations from x, y, z. Okay, so we have 0, 0, 0, 0, 0, 1, 0, 1, 0, then 0, 1, 1, 1, 0, 0, 1, 0, 1, then 1, 1, 0, 1, 1, 1. So para makuha nyo yung sagot dyan is kailangan po sundin nyo yung truth table na diniscuss natin earlier and follow the equation which is f, which is equal to x plus y multiplied to z. Then you will get your answer for that. Okay, so that would be all for your second week. Okay, so